All right, everybody, we're going to do Fall 21 Test 3, Mechanism, Fall 21 T3, Part 4, Mechanism, Question 4A. We're going to be putting a tertiary group on one position and a carbonyl on the other. If you had to guess which one's first, you should be able to do so. What kind of a director is a hydroxy with its lone pair? It's a powerful ortho pair director. Why don't you put the one on that's para first, which is this bond right here? Because that's what happened. And how do we do this? Well, we're going to say red first, blue second. We're going to put a lone pair on our halogen. We're going to make a bond to the aluminum. And we're going to skip forward to the part where it breaks off. And you get this. Tertiary cation. Very nice. And you're going to need this catalyst. It's not quite the catalyst anymore. It's got an extra chloride. The other day, I said you could do this mechanism by using the lone pair on the ortho pair director or not. And when I did it that time, I used it. This time, I will not. It's optional. Please use the pi bond that's attached to the para position. It's the only one that's going to work. And what we have here is our, yeah, I made it blue. Didn't change. We need to put a new bond on here to a tertiary carbon that goes CH2COCl. And a cation is here. The part of the pi bond that did not get a group is the one that has the cation. It's always adjacent to the one that got the group. Cl minus comes off, grabs H, sigma becomes pi. It's called re-aromatization. It's really fast. Not liking my choice of new bond being red anymore because it's overlapped with red. There we go. Nice. Yeah. Okay, beautiful. That makes not what's shown. I'm going to redraw my benzene the way I like to draw it better. Get a little rotation on it. In the para position, we have this tertiary group. CH2COOCl. Time to use aluminum chloride again. I told you it's for putting carbon groups on benzene. First step, same as the first step before. Second step, same as the second step before. Hey, this is even different than the one we did in the lecture. And it's perfectly acceptable. I like having alternate ways. You don't have to show the triple bond from C to O. You can show a resonance form. CH2, C, double bond O, cation here, plus our species Cl, AlCl3 negative. Where's the next group going? It's going here. Meta to the OH. Better use this pi bond right here. Don't have to break the pi. making a bond to a cation. You don't have to compensate by breaking a bond. And you're almost finished to get to the middle box. And that's just a hair big. There we go. And we're gonna go here. Yeah, and we got a cation here. We got our tert-butyl, or it's not butyl, tert sticking down there. Got a CH2 carbonyl, and that arrow was still too big. There you go. I think you've got that. Yep. And most importantly, you've got an H right here that the chloride's going to come and grab. And I'm going to stop the video here. And then I'm going to just copy paste this next part onto the next page, and so we can spread it out nice. And you don't have to copy anything. You've done your copying.